Hi everyone, this is the second pre-class video on module 1, that is representation of power system components. Myself Dr. M.J. Chandrasekhar, Associate Professor, Department of EEE, SABIT. In this video I will be explaining what is per unit value, what are the advantages of per unit value, how to select the base values and how to change the base value quantities, and also I will be deriving to show the per unit impedance or reactances of a transformer is same irrespective of the side on which it is computed. Now we will see what is per unit value. Per unit value is nothing but per unit value, if you want to define for any quantity, is defined as the ratio of actual value in any unit to the base value in the same unit. So that means per unit value is equal to the actual value in any unit to the base value in the same unit. Let us see what are the advantages of per unit quantities. What are the advantages of per unit quantities? The per unit value is same for both phases of the transformer, that is whether it is a single phase or a three phase, the per unit quantity values are same. The per unit value once expressed on the proper base will be same when referred to either side of the transformer, that is primary side or secondary side, the per unit value of that component remains same. The variation of values in any smaller range, hence the errors involved in per unit computations are very less. Usually the nameplate ratings will be marked in per unit on the base of nameplate rating. The chances of confusion between the line and phase values in a three phase balanced system is reduces. So these per unit values provides more meaningful information, and also the per unit impedance values on either side of the three phase transformer is same regardless of the type of connection, whether it is star star or a star delta or delta delta transformer. So what are the disadvantages of this? If the proper bases are not chosen, then the resulting per unit values may be highly disturbed. This may cause confusion to the user. However, this problem can be avoided by selecting the base MVA nearer to the high rated equipment and the convenient base kV in any section of the system. This will be understood by analyzing the single line diagram for per unit value calculations. So how to choose the base values, that is very interesting. So the first what we have to do is, we have to choose the base voltage represented in kilovolts and VB, and SB is the base power which will be in always in MVA. We have to select this in any one part of the system. These values may be the rating of the same component. So this we have to choose at any part of the power system, whether it may be generating side or load side. Sometimes they will give this information for the calculation. If it is not given, we have to consider the largest generator in the power system rating as the base. And the second point is, a two winding transformer separates the whole power system into two parts, and a three winding transformer separates the whole power system into three parts. The third consideration is SB, that is the base power remains same throughout the system. Base power remains same throughout the system, but VB value voltage changes in the power system sections, because section when we have the transformer. Suppose in a power system if you have two transformers, then the whole power system is divided into three parts. Example, if you consider this power system, see here, this power system I have considered, this is load. So, this is one power system. So, if we have a two transformer T1 and T2, it separates into three parts. See here, this is one part, electrically separated. See here, this is one part, this is second part, this is three. That means two winding transformer in a power system, it will divide the whole power system into three parts. So, base voltage here and here it will be different. This is base voltage generator side, this is transmission line side, and this is load side. Totally these three values are different, but base power remains same. Why? Because the whole power system is operating at some power based on the generation. That power we are considering it as base power. Next one is the per unit impedance of any equipment is given on its three phase rating as the base. For a three phase transformer unit made up of three single phase units, then the three phase rating will be, suppose if it is consisting of three single phase transformers, then what is the three phase rating? Three phase rating is 3 multiplied by single phase rating of the transformer, which is marked in MVA. Example, 3 single phase transformer, each single phase transformer is 100 MVA, then the three phase rating of that transformer is 3 multiplied by 100, that is 300 MVA. But voltage, suppose single phase transformer is rated at 11 kV, then if the transformer connections are delta, transformer connection is delta means line voltage and phase voltage are same, then VL is equal to V phase, that is 11 kV. Suppose if it is star, then line voltage will be different from phase voltage, and in that case we have to consider the phase value as root 3 times of voltage given for single phase. Voltage given for three phase voltage if you want, then it is root 3 times of the given single phase voltage. This is how we have to consider. The per unit impedance of a three phase transformer made up of three single phase unit in the per unit is the per unit impedance, and that is what I told. Suppose if it is made up of three single phase units, then it is considered from the single phase units calculation for three phase. Similarly, we can find the impedance in per unit on rating. Impedance per unit impedance on rating, if you know, that means individual component impedance value if you know, then we can find that on base is equal to, this is given by SP by SR into VR by VB whole square. So, this is the formula we use to find the per unit value of impedance on the base. So, the derivation of this will also be shown in this video. So, we will see the same, changing the base of a given unit. So, let us consider the per unit impedance on the per unit impedance. Let us write this, per unit impedance on the common base is equal to, so actual value divided by base value is the formula. So, Z divided by, the formula for ZB is VB square by SP, VB square by SP. So, this is given by Z into SB divided by Vb square. This is equation 1. Similarly, per unit impedance on the machine rating as base is equal to Z divided by Zr. So, this can be written as Vr square divided by Zr. So, this can be written as Z into Zr divided by Vr square, equation 2. So, what we do, divide equation 1 by 2. What we will get? Z per unit on base divided by Z per unit on rating is equal to ZZ get cancel. You will get ZB by Zr into Vr comes to numerator, Vr square divided by Vb square. So, if you simplify this further, you will get Z per unit on base is equal to Z per unit on rating into SB by SR into Vr by Vb whole square, Vr by Vb. So, this is the formula we use to change the base of a given per unit value. Next, we will see the derivation of finding the per unit impedance of a given component from old base values to the new base values, and also we have to select this is the question they have given in the external exam. I told you how to select the base values, and in the previous derivation, I told you how to derive the changing the base values. So, next we have the derivation regarding showing the per unit reactance of the power system is same on both sides of the transformer. So, let us consider a transformer in which it has two windings. So, primary and secondary. See here, this is primary winding, it has current I1 and V1 is the terminal voltage. Similarly, here I2 and V2. So, V2, I1, V1, I2, all these are known. These are the voltage and currents in the primary and the secondary. So, these V1, I1 are nothing but base values of primary winding. This is primary winding, this is secondary winding. V2 and I2 are nothing but these are the base values in the secondary winding. Next, let us have the base impedance, that is V1 by I1. Similarly, the base impedance in the secondary is V2, I2. So, we know that Z2 is equal to Z1 into N2 by N1 whole square. So, this is nothing but the total series impedance of the two windings referred to secondary. By having this, we can write Z1 per unit. Z1 per unit means primary side per unit value is equal to actual value divided by base value Zg1. So, Zg1 is known V1 by I1. This is equation 1. Similarly, we can find Z2. We can find Z2 per unit. Z2 per unit. Take one more slide and tell Z2 per unit. So, Z2 is nothing but secondary side per unit value impedance is actual value divided by base value. So, Z2 divided by V2 by I2. I2 comes to numerator. This is equation number 2. So, let us consider these equations 1 and 2 to get the final answer. But transformation ratio, we know that V2 by V1 is equal to N2 by N1 is equal to I1 by I2 is equal to K. This is the transformation ratio. So, with this we can get V2 is equal to V1 into N2 by N1. Similarly, we can get I2 is equal to I1 into N1 by N2. So, this is equation 3, this is equation 4. What we have to do here is equation 3 and equation 4 is for V2 and I2, we have to substitute in equation 2. So, we will get Z2 per unit is equal to Z2 into I2, I1 N1 by N2 whole divided by V2. V2 is V1 N2 by N1. So, if you simplify this, we will get Z1 V1 by I1. If you simplify this, we will get Z2 this is given by Z2 into I1 by V1 this is how we will get. This is nothing but your Z1 per unit. So, here it is proved that Z1 per unit is equal to Z2 per unit. This means in a transformer so primary side or secondary side per unit value of impedance, if you calculate, they are same.